This is Derivatives Day 1, and we're going to start a unit that kind of is the introduction to calculus. And don't let that scare you. Calculus is just kind of the next class that's after pre-calc. And derivatives are not really that tricky once we kind of get past figuring out what they are. And derivatives have to do completely with figuring out the slope of a line, which you've done many times. But instead of finding the slope of the line, we're going to find it between 2 points or at a point on a curve. So you're used to finding the slope of a straight line, and now we're going to transform your slope idea into finding the slope of a line that actually curves. So earlier you've learned the slope of a line indicates the rate at which the line falls or rises, so the rate at which it goes up or it goes down. So for a line, the slope is the same everywhere along that line. It never changes. When we have a line like you guys are used to, you have how far over you went and then how far down you went. So you have the change in x, and then you have the change in y, which is essentially rise over run. You're very used to that. And there are two main ways to determine the slope of a line. You can do this slope formula from a long time ago. So y2 minus y1 and y2 minus y1 and then x2 minus x1. That can find you the slope. The other thing you can do is look at the graph and count. So if you have a really nice graph with grid lines on it, you could just look and count how many over and then how many down or up for that matter. We'll just say look and count. And you can figure out the rise and the run that way. When you move on to the slope of a curve, now we're talking about it changing from point to point. So there are some places where the curve is very steep and its slope is different than the places where the line is not very steep. So here, if I were to draw a line and a tangent line at that point, it's pretty level. It's almost a constant function just straight across, and my slope is not changing at all. If I do a line over here, let's say, another tangent line where I just touch at one place, this one's increasing, slope is going upward, and it's quite a bit steeper than this line that I drew earlier. And same thing on this side, if I draw another one, kind of sneak in a tangent line right there, this one is decreasing at a pretty significant rate, maybe even the same one as this one because I put the dots at almost the same place, but you could put a dot just about anywhere. Draw a line, and your job now is to figure out the slope at that particular point, knowing that no matter where I move along the curve, I could draw a different line and have a different slope no matter where I am along the curve, which makes it kind of challenging because then you got to talk about, well, where are you on the curve so that we all find the same slope. So determine the rate at which a graph rises or falls at a single point. You can find the slope of the tangent line, which we were kind of talking about. Remember that tangent lines touch the curve at one point. So they don't go through it, they just touch it at one place. So in order to start talking about derivatives, we kind of take kids back to talking about how to plug things in, which doesn't seem very difficult or very calculus-y. But in order for us to get to derivatives, kids usually kind of have a struggle with plugging stuff into the equation. So we're going to start with 3x minus 2, and we're going to plug all of this stuff in one at a time. First one says f of a, so I'm going to plug an a in, so 3a minus 2. Next one says x, so I'm really just plugging an x in for x, nothing is changing there. This time I'm going to plug in x plus 2, so I'm going to have an x plus 2 like that. And we don't need to multiply them out right now, just getting used to how things get plugged in. Next I got x plus h, so this is going to be 3x plus h, and then minus 2. And then we kind of get this whole thing, which is kind of a big animal. It has two different parts. It has f of x plus h, which we just did. And then we're supposed to subtract f of x, which we also did up here. So I'm going to take this guy, 3x plus h minus 2, and then we're going to subtract, that was the first part, and then we're going to subtract f of x, which is going to be 3x minus 2, which is really just the function. I didn't do anything fancy to plug that x in, and then all over h. And we will get into doing some problems where we are going to clearly simplify. We're going to reduce this down. We're going to do it for this one too. But this is usually the challenging one for students, is getting all of these bits kind of plugged in where they need to go. So you end up with 3x plus 3h, just doing some distributing, minus 3x plus 2 over h. 2 and 2, 3x and 3x, so I'm left with 3h over h. The h's cancel and I'm left with 3, which is pretty awesome. Doing this all again, except this time the x is going to be squared. So plugging in an a, I've got 3a squared minus 2, 3x squared minus 2. This one will be 3x plus 2 squared minus 2. What's going to get you in trouble is you're going to forget that this is x plus 2 times x plus 2, that you're going to have to FOIL that. Lots of kids want to just distribute a power, but you can't do that. Write this twice and then FOIL it out. This one will be 3x plus h squared minus 2. And then kind of putting that all together, for number 5, we're going to have this guy, which is this right here, then minus the f of x function, which is just the thing we were plugging into, so 3x squared minus 2. I'm going to do a little simplifying here. Foiling this, I end up with 3x squared plus 2xh plus h squared, oops, parenthesis, minus 2, minus 3x squared plus 2, just kind of distributing that negative through. Right away my 2's cancel, so I'm going to distribute the 3x squared plus 6xh plus 3h squared minus 3x squared. These guys will cancel. So I'm left with 6xh plus 3h squared all over h. This is where we have to review a little bit about what you can cancel. Each of them has an h, which means I can take one h from every one. So I'm left with 6x plus 3h's. And we're going to talk more in the next lesson about how we're going to use that in order to find our slope. So it's going to be something we're going to use a lot. These two guys, just being able to plug all that stuff in where it goes. Last part we're going to talk about, now we're going to talk about graphing a tangent line. So using this graph, we're going to find the slope at each point. So what we need to do is first go to this x value, which is x equals 3. So 1, 2, 3, that dot right there. We're going to draw our own tangent line. And this is the part that kids don't like, because I'm going to draw a tangent line, and you might have drawn yours slightly different than me. So we might end up with slightly different slopes. So what I'm attempting to do is drawing a tangent line. I'm going to get a little sheet of paper here with a straight edge on it. And I'm trying to draw a line that will only touch the graph one time, and it's going to touch it right at that dot. So I'm kind of just balancing this piece of paper, trying to get it to touch that dot once without actually touching the function. And that looks pretty good, so I'm going to go with that. So drawing that through, that's going to be my tangent line, and then I'm just giving the slope of this line. It'll kind of be an estimation. Again, yours might be different than your neighbor's, so when you compare answers, you're just looking for something close. So if I count the slope of this line, it kind of looks like I'm going up 2 over 1. Maybe a little shy of that, so maybe it's fine. I'm kind of going through that corner, so let's go 1, 2, 3, 4, 5, and over 3. We can go with that slope, and as you can see, I'm guessing, like it kind of looks like it was a 1 over 2. Didn't quite work out the farther I went, so I kind of spread out the points a little bit, looking for another corner that it's going through. Next, we're going to do 0. So 0 is right in the middle, going to that point right there. We're going to draw another tangent line to it, and it doesn't matter if you're on this side of it or over here. You're just attempting to draw a tangent, so you're trying to touch the line only once. This one's going to be a little trickier. We'll try that line right there. So it looks like this guy might be going, no, I can't tell those apart. Bad drawing. Let's go 1, 2, 3 over 1. 1, 2, 3 over 1. It's a little shy of that, but we'll go with that. And that was downward, so down, oops. Yeah, down 3 over 1. That was right. Excuse me. The last one is at -2, which is right there. So again, kind of balancing my sheet of paper, estimating my tangent line, kind of draw my tangent line. It almost looks like it's going to be horizontal. And the slope of any horizontal line is 0. So I don't have any rise. I do have a lot of running, but no rising. And so you're just drawing yourself a tangent line, trying to get close to the function, touching it one time at the dot, and then estimating the slope of that line. You're not going to like this part because this is where you can be different than your neighbor. There's no guaranteed answer unless I provide the tangent lines for you.